So Euler's method is used to find particular solutions of a differential equation given in the form y prime is equal to capital F x of y. And so the graph of the solution passes through the point x 0, y 0. And this point also has a slope of capital F x 0, y 0 at that given point. And so basically you use the starting point and the direction of the slope, and then there's also like a step which is like the intervals that you can break it up in, which is given by h, and you can move along the tangent line until you reach a point where x is like x sub 1 and y sub 1. And so here's an example of the way Euler's method actually pretty much works. So in this given graph, we have an example of just the ordinary graph equation, and then you have an example of how Euler's method works, because it essentially is giving you an approximation close to the actual solution. And from the diagram here, you can obviously see h given here in the little intervals, and you can also see their x initial and y initial, and you can also see how the slope affects it and ultimately helps you get to a closer solution. So Euler's method, you can essentially just plug it into sort of parent functions that ultimately help you give approximations to the exact solution of a differential equation. And so for the x direction, the parent function is basically x sub n is equal to x sub n minus 1 plus h. And in the y direction, it's y sub n is equal to y sub n minus 1 plus h times capital F the x n minus 1 y n minus 1.
First of all, this is the first example using Euler's method to approximate the particular solution. The example problem we have is y prime is equal to x minus y, passing through the point 0, 1 when your h is equal to 0.1. So pretty much if you look at your equation, it's y1 is equal to y sub o plus h times f of x sub o y, comma y sub o, parentheses. So what you do is plug in your starting values. Your y sub o is 1, your h is 0.1, and you plug in for the f of x sub o, y sub o part, you plug in your 0 and 1 into the equation that you originally had, which was x minus y. So your x is 0, your y is 1, 0 minus 1 is 1. And then you multiply that all together, and for the first part you get 0.9. And pretty much you repeat that for all your y values. But your x values, to get your x values for all the different ones, you would just do x sub o plus h. So your initial x sub o value is 0 plus 0.1, and that's how you get each of your continuous x values. And then you will put them all into your chart. This is example 2 of applying Euler's method. In this problem, you use the solution to the differential equation to find the actual y values. You approximate it in example 1, and then you compare them to each other to calculate the percent error. To calculate the percent error, you will use the formula, the absolute value of the exact minus approximate over exact times 100 will give you the percent error. The solution to the differential equation is given to you above. So for example, you will take your first x value, 0.1, plug it into the equation, the solution to the differential equation, minus that by the approximation you got, which was 0.9, the absolute value of that over the exact answer, times 100, and it gives you 1.06%. We calculate the rest of the values for the rest of your x values, and you get 2.09%, 2.02%. Next, we go to example 3, which is just applying Euler's method similar to the first example, but with a different kind of problem, a more complicated version. So pretty much you will follow the same steps where you will plug and chug your numbers into the kind of parent functions. So y1 is equal to y sub o plus h times g of o. Pretty much you will plug in what your initial y sub o point is, which is 0, plus your h, which is 0.1 times the answer to your equation, which is 2 minus e to the negative 4x minus 2y. You will plug in 0 for x and 1 for y, and you will get negative 1. And then you will multiply all that out and add them, and you will get 0.9 for your first y1 value. And then you would do, for your x value, you would just do x sub 1 is equal to x sub o plus h. Your x sub o is 0, and your h is 0.1. You add them together and you get x sub 1 is equal to 0.1. And you repeat this step with your the new values you keep generating. And you get, for the first value 0.1, you get 0.9 as the y value. For the second one, 0.2, you get 0.853. And for the third one, 0.3, you get 0.837. These are pretty much your homework problems. They model the examples we presented in our lesson. So if you have any troubles, go back into the video and watch how we did the problems. Enjoy.